Hi there. So in this section, we are looking at an introduction to factoring, and more in more pointedly, we're going to be looking at factoring out the GCF as well as factoring by grouping. Okay, so we'll start with the two examples here on the front page in the boxes. It says you're building a raised bed vegetable garden, and you'd like the planting area of your garden to be 64 square feet. And they want us to know here, well, what are some possible side links then that you could use to construct your garden? So in other words, what are possible factor pairs of 64? What are ways that we can multiply to give us 64, right? Because remember, we're talking about area, so area is equal to length times width. So we're trying to figure out what ways, what numbers can we use to multiply together to get us to 64, okay? So we know that it could be perhaps a 1 by 64, right? Will 2 go into 64? Yeah, so it would be a 2 by 32. 3 won't go into 64 evenly. 4 will. 4 times 16. 5 won't. 6 will not go into 64 evenly. 7 won't. 8 will. 8 by 8. 9, 10, 11, 12. None of these are going into 64 evenly. 13, 14, 15, 16. Once you repeat yourself, oh, I repeated myself at 16, then I know I can stop. Those are all of the possible factors then of 64. So these are the ways to multiply to give us 64, okay? So that's what it means to factor an integer. You want to think about all of the ways that when you multiply two numbers together, you get that original integer, okay? So that's what it means to factor an integer versus factoring a polynomial, all right? So it says your neighbor, Mr. Jones, also decides to build a raised vegetable garden. His garden has a planting area that's given by this expression and a width of 2x. They want us to find the expression then for his length. So formula for area is still the same. Area equals length times width. Let's fill in for the area. So our area is that, and I'm going to write that in descending order. So I've got my 10x squared plus 4x equals, the length we don't know, but with the width we know is 2x. All right, so now I'm trying to solve for that length, so I'm going to divide by 2x. So everything's going to get divided by 2x over here. So that cancels out. So then my length equals, I just divide. So 10 divided by 2 gives me 5. Where do I have the most x's? Up top. One more. 4 divided by 2 gives me 2. X's cancel out. So that would be the expression then for my length. Okay. So then what we can say then is that we now know then 2x times 5x plus 2 would give us our overall area of that 10x squared plus 4x. And sure enough, if I distribute through there, that's exactly what I'm going to get, is this quantity over here on the right. So what it means then to factor a polynomial is that you want to be able to rewrite that polynomial expression as a product of other polynomials that when they multiply together, they're going to give you that original, okay? So we're going to first look at factoring out our GCF, and GCF is the greatest common factor. So when it comes to factoring polynomials, you're going to be looking for the highest number and least letters that they have in common. Highest number, least letters. So example 1, I'm going to do A and B with you and let you try C on your own, okay? So in letter A, I'm trying to figure out what's the highest number that 20, 12, and 16 all have in common. Here's a way to get you started. Some of you might look at it and say, oh, automatically you know what that number is, okay? I'm going to start with the value of 4, because I can definitely tell it. I know 4 will go into all of those, and then I'll show how we can then see if we need to go any further. So I'm going to put a 4 with all of these. All right, so now we're going to say, okay, well, 4 times what gives me 20? That'd be 5. 4 times what gives me 12? That'd be 3. 4 times what gives me 16? That'd be 4. So we now know that they all have a 4 in common. If 5, 3, and 4 still had something in common, I'd keep going, but they don't. 5, 3, and 4 have nothing left in common, so that tells me then that my GCF here is 4. Okay? All right, so now let's move over to our next example. So I have 40m cubed and 32m to the 5th. Okay? Now this time, let's say for example, yep, I see, you know what, 4 will go into both of these again. All right, so I just want to show you, like, say for example, you don't see the highest number right from the start. So I say, yep, I know 4 will go into both of these. So let's do 4 again. I'm not gonna worry about the letters. We'll do the letters at the end. So I ask myself, okay, well, 4 times what gives me 40? That'd be 10. 4 times what gives me 32? That'd be 8. So I'm gonna circle these 4s because they have that in common. Now 10 and 8, don't they still have something in common? They do, so I keep going. All right, so now what's the number that'll go into both 10 and 8? If you agree, that'd be a 2. 2 times what gives you 10? Sorry. Um, 2 times what will give you 10? That'd be 5. 2 times what would give you 8? That'd be 4. So now I circle these 2's. Now here's how I know I can stop. 5 and 4 don't have anything in common. So my GCF then, multiply 4 times 2, which is 8. So there's my GCF, that's my highest number, and now I want the least letters that they have in common. Well, the top one has 3, the bottom one has 5, so I pull the smallest, m cubed. Some of you might have been thinking 8 from the beginning, and if you had, like, I know you would have gotten there much quicker, and I showed that actually on the solution key. If you were thinking 8 to begin with, then you would have had 8 times 5 and 8 times 4. You would have circled those 8s they had in common, and you would have seen right there 5 and 4 have nothing in common, and you would have been straight away to your answer, okay? I just wanted to show you that in case you don't see the highest number to begin with, how do you get there, okay? I'll let you try letter C on your own, but regardless, when you're picking out your GCF, it's the highest number and least letters that they have in common. All right, let's flip it over then to the next page. On the next page, we are factoring out our GCF for polynomials. When you do this, you're still picking out the highest number and least letters that they have in common. You can always check yourself in the end by distributing. And you want to make sure that whenever you have pulled out your GCF, that everything left in parentheses doesn't have anything in common. Okay, so I'll demonstrate that here in just a moment so that you can see what that would look like in case you were to make a mistake. All right, so let's do A, B, and D here together, and then I encourage you to pause the video and finish up that problem. Okay, so in letter A, what's a number that'll go into both 12 and 10? And it's the only number, right? Which is 2. The highest number, least letters. Well, that one has 1x, that one has no x's, so I don't pull out any x's. So I pull out a 2, and then now I'm basically like I'm undoing distributing. So I'm asking myself, 2 times what gives me 12? That'd be 6. X. 2 times what gives me 10? That'd be my minus 5. So that now if I do distribute, I get this back. Or in other words, it's another way to say this is that they both had a 2 in common, go through and divide both of those terms by 2. And you write your leftovers on the inside. But you can check yourself by distributing. 2 times 6 gives you 12x, or 2 times 6x gives you 12x. 2 times negative 5 gives me that negative 10. Here's how I know that I pulled out the GCF. 6x and negative 5 do not have anything left in common, so I know that this would be my final answer. Okay. Let's move over to letter B. Highest number, least letter. So what's a number that'll go into 5, 10, and 15? And hopefully you agree. I can pull out a 5. And according highest number, least letter. So I have 3, 2, 1a, so I can pull out 1a. All right, so now I'm going through and I'm dividing each of these by 5a. So, or in other words, I'm saying 5 times what gives me 5? That'd be a 1. Now when it comes to your letters that are left over, just subtract. So 3 take away 1, so I have a squared. You don't have to have that 1 there. You can just have a squared if you like. 5 times what gives me negative 10? Be a negative 2. Get my letters. 2 take away 1. That'd be a. Plus 5 times what gives you 15? That'd be 3. Take away your letters, so a take away a. 1, 2, and 3 don't have anything in common letter-wise. A squared, a, no a, so I don't have any letters in common. So I have pulled out my GCF. If you distribute 5a through this parenthesis, you should get that back. Okay, a way to check yourself. All right, letter D, I'm going to purposely pull out the wrong number first, okay, so that you can see what I mean by if you don't pull out the highest number. So let's say, for example, here 18 and 30. Oh, I say, you know what? They're both even. I could pull a 2 out. So let's do that. So if I pull out a 2, then I'm pulling out my highest number, least letter. So they both have 1 M and how many N's? 2. All right, so if I just pulled out a 2mn squared, okay? 2 times what gives you 18? I'll give you 9. Subtract your letters, so the m's are good. 3 take away 2, so 1n. Minus 2 times what gives you 30? Agree, that's a 15. Subtract your m's. 4 take away 1, so m cubed. Your n's, 2 take away 2, so I don't need any more n's. Now, this is what I want you to always be on the lookout for. Inside that parenthesis, do those two terms have anything in common? Letter-wise, they don't, but number-wise, they do. 9 and 15 still have what in common? If you agree, they still have a 3 in common. So what that means is, from the beginning, I didn't pull out the highest number, but it is at least now a starting point. If they both have a 3 in common, take that number that they have in common, which in this case is a 3, and multiply it times the number that you already pulled out. So 3 times 2, I should have pulled out a 6 here. And then we already know we've got our letters right. So now 6 times what gives me 18? It'd be a 3, and then the letters, you know how we did that. We just subtracted. 6 times what gives me 30? That'd be a 5. Let me clean that up a little bit better. There we go. That'd be a 5. And then 4 take away 1 on the m cubed, and then the n squareds, right? Now at this point, 3 and 5 have nothing in common. Letter-wise, we still don't have anything in common. That is my final answer. Okay, so just always make sure when you pulled out your GCF that what you have left over in parentheses does not have anything left in common. Okay. All right, so now down below in example 3, we're going to also be pulling out our GCF. But in these, I'm going to have you practicing pulling out a -1, because as we move forward in factoring and in our next couple of sections, factoring is much easier when your leading term is positive, and so it's always legal to factor out a -1, for example. So what it means by in order to do that is here in example 3. And I'm saying here, make sure that your leading coefficient is always positive, okay? So between 5 and 10, they both have what number in common? I hopefully agree. They both have a 5 in common. But instead of pulling out a 5, let's pull out a -5. So that inside my parentheses, what I have left over here is going to be a positive value. They don't have any letters in common, right? Because one n, no n's, so you pull out the least letters. So no n's is smaller. All right, so pull out a -5. So then -5 times what gives me -5n? So left over just an n. -5 times what gives me what kind of 10? To be a -2. Final answer. Okay, let's do one more so you can kind of demonstrate again. So between -h and -10, what do those two terms have in common? The only thing they have in common is a -1. So I'm going to pull out that -1. So if I'm dividing by a -1 here, that's going to leave me with a positive h. -10 divided by -1, that's going to leave me with a positive 10. Okay. So again, as we move into the next couple of sections, pulling out a negative so that your leading term is positive is going to be helpful for us. Okay. All right, let's scoot on down to example 4. In example 4, it wants us also still to factor out the GCF. Now remember, factors are separated by addition and subtraction signs. So I'm sorry, I said factors. I meant terms. Terms are separated by addition and subtraction signs. So this is a term, and this is a term. Between those two terms there, what do those two terms have in common? And hopefully you agree, they both have an n plus 8 in common. So I'm going to factor out that n plus 8, and then I'm going to write what I have left over. So out of the first term, I have m left over, and out of the second term, I have that -7 left over. And that's my final answer. Okay. So terms are separated by addition and subtraction signs. So here's a term, and there's a term. Now, within each of those terms, they both had an n plus 8 in common, so I factored that out, and then I wrote what I had left over, m minus 7. Okay, I'll let you pause the video and finish up this page, and let's flip it over then to the last page. On the last page, we're looking at another method for factoring, and this is used to, it's called factoring by grouping, and it's used to factor polynomials with 4 terms, okay? The first thing that you always ask yourself is, does it have a common factor? If it does, pull it out, all right? After that, you're going to group the first 2 terms together and the last 2 terms together so that everything has something in common. And then you're going to factor out what each of those parentheses have in common. You should end up with a repetitive factor, and then we're going to go from there, okay? All right, I figure it's probably easier for me to demonstrate than talk you through all of those steps. So here, in example 5, I'm going to do the right-hand side here with you, B and D. All right, so if I'm looking at letter B here, I ask myself, does it have a common factor? So number-wise, 2, 3, 4, and 6, they don't all have something in common. So I'm not going to be able to pull out any numbers, and I can't quite pull out letters either because I've got an M, 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 but no M's. And this one has N, 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 but no N's. So I can't pull out, they don't have a common factor. So then I'm going to immediately go to factoring by grouping. So I group the first two terms together and group the last two terms together. Every once in a while you have to rearrange them, but just so you can be aware of that. All right, so out of the first, rearrange the terms in order for them to have things in common is what I meant. So the first two terms, they both have what in common? So now I can factor out an M, and I write what I have left over. So if I factor out an M out of that first term, what I have left over, that'd be 2M plus 3N. Now out of the second parentheses, what do 4 and 6 have in common? And hopefully you agree. They would both have a 2 in common. Now notice how they're both negative. I'm going to go ahead and pull out a negative 2 because I will make this note. In order to factor by grouping, your goal is for the parenthesis part to be identical. And so if the parenthesis part isn't identical, then you're going to have a problem. You're not going to be able to factor by grouping. So I know I can tell from here that I'm going to need a 2M plus 3N. And if I'm not going to be able to get a positive in my parentheses, then I'm not going to be helping myself any, okay? So I'm going to pull out a negative 2 because they both have negatives in them, and they both have a 2 in common. And then letter-wise, I can't pull out any M's, but they both have an N in common. All right, so now negative 4 divided by negative 2 would be a positive 2. And then I already have my N, but I need an M. Negative 6 divided by negative 2 would give me a positive 3. And then 2 take away 1, so 1N. So now you can see, just like on that previous page, here's a term and here's a term. Both of those terms have the same parenthesis part. That's what they have in common. So now I'm going to factor that out, 2M plus 3N, and then write what I have left over, M minus 2N. Final answer. Okay? If you were to FOIL that final answer there, you would get the original problem back. So that's a way to check yourself. I didn't mention that. Okay? All right, letter D. All 4 of those terms, what do they have in common? No letters, but hopefully you agree they all have a 5 in common. So I'm going to factor out that 5 and then write what I have left over. So I'm dividing everything by 5. So 10 divided by 5, that's going to be 2x squared. 5 goes into 15 3 times, so minus 3x. 5 into 40 gives you 8x. Plus 5 into 60 will give me, what, 12? All right. Then I've got 4 terms here, so I'm going to group the first 2 together, group the last 2 together. It technically would have been legal here for me to combine those, okay? But we're not quite there yet, so I'm going to still treat it like I've got 4 terms. All right, so I'm going to bring down this 5. I'm going to bring down that bracket. All right, out of the first parenthesis, what do those 2 terms have in common? Hopefully you agree, just an x. So I'm factoring out an x. I'm going to write what I have left over. So that would be 2x minus 3. So then when I come over here, whatever I factor out, I'd like for the parenthesis part to turn into 2x minus 3. So between 8 and 12, they both have what in common? Hopefully you agree, they both have a 4 in common. And because I need that first term to be positive, I'm going to bring out a negative 4. So then negative 8 divided by negative 4 is going to give me a positive 2x. Negative 4 times what gives you 12? Negative 3. And that's exactly what I wanted. I wanted those parentheses to match up. So now I bring down that 5 that's on the outside. These 2 terms have what in common? That parenthesis part, 2x minus 3. And then write what I have left over, x minus 4. And that is your final fully factored form for that polynomial. And again, if you were to FOIL and then multiply it times 5, you would land with the original problem as a way to check yourself. All right, that finishes this section. Thanks a lot. Bye.